And next we have the outer solar system. Here, Jupiter and Saturn are still cooling down and are beginning to take on their recognizable appearance. They have captured numerous asteroids and small objects, which have become their minor moons. Their main moons, including icy Europa and enigmatic Titan, are also cooling and most likely could develop oceans. And our first stop is the giant planet Jupiter. Here is Jupiter in all its glory. It looks truly majestic. It really is a majestic planet. Its mass is already almost one Jupiter mass. So Jupiter has really reached the mass we're used to seeing. It's almost a perfect match now. At the moment, its diameter is listed as 263,456 kilometers. And it has already cooled down to 966 degrees Celsius. It also says that it has 97 moons. I'll switch to automatic photo mode. Of course, it's amazing. So many bands, a lot of textures, but on the dark side, you really can't see anything. Switching to HDR mode. Well, in HDR, thanks to the fact that Jupiter hasn't completely cooled down yet, we can see the glowing upper layers. The orbits of its main moons look like this. Here we have Io, here is Europa, here is Ganymede, and here the orbits no longer intersect. In an earlier video, where I showed you the solar system at a slightly later period, back then the orbits of these three moons actually intersected, but here, as we can see, the situation has already become more stable. And also near Jupiter we can see its moon Amalthea, and here is another moon. Well, let's briefly look at its four main moons. And the first one, of course, is Io. It looks like this, already yellowish, and very much resembles the one in the solar system at the present time. It has already cooled down to a temperature of 685 degrees. Here I've landed on its surface, and this is how Jupiter looks in its sky. Let me also turn on auto mode. It's so huge in the sky. It's interesting to find out the distance. It says 5.22 astronomical units from the Sun. Next, let's fly over to the second moon, Europa. Here's the fascinating Europa. Apparently, there are still some hot spots left. It has cooled down to a temperature of 544 degrees Celsius. And it certainly looks quite interesting. Next is Ganymede. Let's see how it looks now. Oh, let's try the automatic photo mode. In this mode, you can't see any glowing on the surface at all, but you can see it in HDR mode, though it's cooled down to a temperature of 594 degrees Celsius. Well, let's fly to Callisto and see what's interesting there. Wow, Callisto looks absolutely incredible. Really unusual, very unusual. Let's try auto mode. It's as if Callisto has a dense atmosphere or something. It says the atmosphere is made of octane. Whoa, let's go this way. Oh no, that was just a deceptive sight, most likely. Switching back to HDR. And here Jupiter looks so huge. Maybe they used to orbit closer to Jupiter. It looks like there's a firestorm on Callisto, but honestly the texture quality is kind of messed up or something. Well, whatever, let's land somewhere around here and take a look. And there's nothing on the surface either, so it really was just a deceptive sight. There's a thin atmosphere here, and here's the view of Jupiter. And if you switch to automatic photo mode, Jupiter looks like this, and you can see the neighboring moons. But if you look at it like this, it almost seems like there's a really dense atmosphere. Well, anyway, it's clear now. Next, let's fly over to Saturn and see what's there. This is how Saturn looks. Let's try the automatic photo mode. Well, it's clear, it's a bit flattened. Its solar day is 10 hours and 39 minutes. It has cooled down to a temperature of 507 degrees Celsius and has 261 moons. And here in the planetarium it says that it has 6 major moons. These are Tethys, Dione, Rhea, Titan, Risolida and Iapetus. Well, I think we can take a look at, for example, the moon Rhea. Let's go there. This is what it looks like. It appears quite white, but there are some heated areas. Makes sense, 652 degrees Celsius. But I'm not interested in these moons, I'm interested in Titan. The most interesting moon is Titan. We're flying straight to it. Wow, Titan, with its atmosphere. The atmospheric pressure is 1 atmosphere. The atmosphere consists of nitrogen, carbon dioxide, hydrogen, water vapor, and carbon monoxide. So many elements. It has cooled down to a temperature of 640 degrees Celsius. In the background you can see Saturn. We're descending to the surface. This is what it's like on Titan's surface. Such a dense atmosphere. Well, more accurately, dense clouds. The sky doesn't really get much light. But here we can see the sun. The distance to the sun is 7.29 astronomical units. And now I want to fly a little above Titan's surface. Here you can see some red areas here. Let's take a closer look at how all of this appears. Everything here on the surface seems pretty flat. So far, I don't see any mountain peaks. I'm curious to turn off the display of the atmosphere and clouds to take a closer look. Here, we have active volcanoes and it looks like there are mountains nearby. Let's try to descend somewhere near the volcano, right around here. Oh no, these aren't mountains after all, guys. Everything here is pretty flat in this area. Alright, let's head over to the volcano. Now I'll turn the display of the atmosphere and clouds back on. There, I'm turning it back on. And this is how the volcano looks here on Titan. I landed not far from this volcano, right here. Everything here is so green, as if there's some kind of vegetation. But guys, this isn't vegetation at all. And in the distance, I think you can see this giant structure or something like that on Titan's surface. Let's also take a look at what the sunset looks like here on Titan. It's kind of reddish. And as night falls, let's see what kind of view opens up, what we can see here. Well, I guess that's a neighboring planet, maybe Jupiter. Oops. And can we see Saturn from here? Unfortunately, guys, you can't see Saturn from this part of Titan. We'll need to move. I've moved a little, and now from this spot you can already observe Saturn. If I speed up time a bit, we'll be able to see the movement of its neighboring moons, the movement of Saturn itself, and the movement of the clouds. And right here, we just had a star rise. Caught the moment exactly. Caught it perfectly. And guys, here's some more information from the description of this system about the next planets, about the ice giants. It says here that the fifth giant planet also acquired many moons. This is an ice giant, similar to Neptune and Uranus. So, as I understand it, we're talking about Planet X. It turns out that Neptune, Uranus and Planet X form a sort of trio. Right now, Planet X has the most moons among the ice giants, but soon it will lose almost all of them. Uranus's large moons cool down quickly because they're far from the Sun. Earlier, Uranus was struck by Boreas, which caused Uranus to tilt onto its side. Neptune's moons have already fully formed, but in the future, they will eventually be destroyed by a familiar, captured dwarf planet. I think you probably know what I mean. I'm talking about Triton. And in fact, here is the orbit of Planet X. I don't know why the description of this system says that it has the most moons. Here it says Neptune has 14 moons, while Uranus has 15 moons. Planet X is actually listed as having 7 moons. That's strange, of course. Well, probably the person just made a mistake in the description. And so, this is what Planet X looks like. It has cooled down to a temperature of 276 degrees, and it has 7 moons. It would be interesting to take a look at them. And here, it only has 2 large moons. The first moon has a diameter of 600 kilometers, and the second is 851 kilometers. So let's briefly take a look at this larger moon. But this airless world is quite unremarkable compared to Planet X. And the smaller moon is actually closer to Planet X. You can see the distance for yourself. I'll also tell you that the distance from Planet X to the Sun is 9.92 astronomical units. And the next planet in the system here is still Neptune. I understand that they will move later on, so Uranus and Neptune will have to switch places soon. But here, Neptune doesn't look very appealing. Look at the patterns it has in the upper layers of its atmosphere. It actually looks really beautiful. I like it. Neptune has already cooled down to a temperature of 156 degrees Celsius. This is what Neptune looks like in automatic photo mode, and we can see its moons in the background. Actually, there's an interesting situation with the moons here. Here's Proteus, which we're familiar with. Let's see what it looked like in ancient times. Yeah, Proteus looks like a square-shaped moon now, but here it's round. There's also Nereid, Ladon, and some others with unfamiliar names. Maybe I just don't know them anyway. But Triton isn't actually here right now, guys. That is to say, Neptune hasn't managed to capture Triton yet at this particular point in time. Let me tell you, the distance from Neptune to the Sun is currently 12.74 astronomical units. I'm really interested in Uranus's orbit, by the way. Take a look, it's marked in red. This is where Uranus is located. Is it seriously just sitting in the Kuiper Belt, or what? Wow, that's something for sure. Let's fly over to it. And here, as mentioned in the description, Uranus is already lying on its side. Its axial tilt is 97 degrees. So Uranus has already gone through its catastrophic collision, and now it's lying on its side, poor thing. And on the surface, the temperature is minus 215 degrees Celsius. As for its moons, here we already have 5 of its known moons: Miranda, Ariel, Umbriel, Titania and Oberon. Miranda looks like this, and its temperature is minus 152 degrees Celsius. Well, let's take a look at the largest moon, Titania, the biggest moon of Uranus. Now this moon already has reddish hues, just like in the solar system at the present time. And here, the temperature is minus 160 degrees Celsius, with a diameter of 1,577 kilometers. And here we can even see that there are canyons of its own on this moon. Actually, if you look at it like this, the canyon here isn't particularly large. I would even say that there's quite an extensive canyon here, so to speak. Here we can see the sun. Let's see how far away it is. The distance is indicated as 15.49 astronomical units. And if we look in this direction, we can see Uranus. Switching to automatic photo mode. Well, Uranus is, of course, shining very brightly. But if you set the exposure to something more or less normal for the human eye, this is roughly how we would see Uranus right now if we somehow found ourselves on this moon. And now guys, let's talk about dwarf planets. The system description states that all the dwarf planets are still in the process of cooling down. Some of them have already developed moons. Triton has almost cooled down and is dancing with its binary partner Tritiea. Soon it will be captured by Neptune. And Pluto has recently captured Charon, forming a disk from which its other moons will soon emerge. And first, let's take a look at Proto-Triton. Here is Triton. It's already cooled down quite a bit, of course. There is already a faint atmosphere made of nitrogen. The average temperature is 257 degrees. And that's what the surface of Triton looks like. Very unusual. We can see the star and neighboring planets. Now let's see where the second component is. Here it is actually. This is Tritiea. There's one thing I'm curious about. If Triton was captured by Neptune, then what happened to Tritiea? Well, of course, it's just a hypothesis that Triton used to be a double planet, so to speak. Anyway, share your thoughts about this in the comments. Next, let's take a look at Proto-Pluto. Here's what Proto-Pluto looks like now. It has cooled down to a temperature of 261 degrees Celsius. It already has 5 moons. And it has a thin nitrogen atmosphere. I'm descending to its surface, and here the landscape is quite barren. Let's take a look at its sky. I think we should already be able to spot Charon in the sky. No, I didn't see anything here except for the star. So I'll tell you the distance to the star. It's 16.15 astronomical units, and to see Charon, I moved to the dark side of Pluto. And now if we look, we can see Charon. Automatic photo mode. If you turn it on, this is how everything looks. Well, I think it's time to go take a look at Charon. This is what Charon looks like. I'll switch to HDR mode and tell you that it's already cooled down to minus 260 degrees Celsius. Besides Charon, Pluto also has 4 more moons, but they're all very small asteroids. Essentially, these are the same asteroids that are now orbiting Pluto. Next, we're flying to Proto-Haumea. Here's Haumea, still in its familiar shape. And right here nearby is the second component. This is Ataisina and Vontamana, so there hasn't been a collision here yet, and Haumea is still in its round form, Proto-Haumea and this dwarf planet Ataisina. I'm going to fly over there now. They've cooled down to a temperature of 154 degrees Celsius. Next, let's visit the dwarf planet Makemake. Oh, Makemake already looks kind of pink here. Interesting. It has already cooled down to a temperature of 144 degrees Celsius. This is how it looks in auto mode. Switching HDR back on. Now we're flying to the dwarf planet Eris. Well, this is what Eris looks like. Let's try auto mode. This is how it looks. It has cooled down to a temperature of 269 degrees Celsius. And it has 1 moon, and here we can see it. This is Dysnomia. At the moment, Eris does indeed have a moon, Dysnomia. And I also wanted to find Sedna here. And here is Sedna, located on a circular orbit here, though it's much farther away than the dwarf planets we just looked at. But let's see what it looks like up close. Here it is, kind of reddish. Its temperature is 131 degrees Celsius. It has a diameter of 980 kilometers and a mass that is 0.2 times that of the moon. This is what it looks like in automatic photo mode. Well, it's quite bright. At such a distance, it probably wouldn't look like this. I'll switch back to HDR and descend to the surface. So, here on the surface of Sedna, let's take a look at the sun. There's the sun. And I'll tell you the distance to the sun from here is 28.07 astronomical units. And here on Sedna, we can also see these craters, quite large ones, and right here there are some really prominent craters. But if you look at it this way, just how far is this distant world from the sun? Now I'll turn on the orbit display as if Sedna is secretly observing the solar system from afar. This is roughly what our solar system looked like 4.535 billion years ago. It's always interesting to look back into history, especially the history of the solar system. If you enjoyed the video, please give it a like and write in the comments what you think about this system in the past. Is everything displayed correctly here? If there are any mistakes, let me know in the comments. Thank you very much for watching, and see you again in the universe.